Alright, so now that we know how to open and close a given file by specifying its name and using the fopen function, let's try and understand a little bit more about what we mean by text mode file access. Right. So text mode essentially means that we are referring to something that is human readable, right. In particular, the contents of a text mode file would typically be in an encoding such as ASCII or Unicode or something like that, which can usually be displayed on screen or printed out. Okay. Now you might imagine that what other kind of file is there, because typically the kinds of files that we are used to are text files. For example, the main.c, the file that we were looking at, actually is a text file, right, in the sense that what it contains is a sequence of ASCII characters that basically indicate the codes corresponding to each of the letters that gets displayed in the editor, and we can edit it. We can directly use a text editor in order to manipulate that file, save it, and then finally compile it. Now this is distinct from, let's say, an actual executable file, right, or a compiled .o file, both of which if you try opening them in a text editor, you will basically see garbage. You won't see anything that makes sense, right. And the reason for that is because those are not really in text format, they are what are called binary files. They are just a stream of bytes. Okay. Now text files in particular have this thing where, let's say, a number such as 1 2 3 4 5 6 7 8 would actually end up using 8 characters to display it or represent it inside the file. What does that mean? It means that it actually occupies 8 bytes of storage on whatever medium it is, whether it's in the RAM or whether it's in an external disk or some other place. It requires those 8 bytes, possibly with a null character if you are using a string, but otherwise it's essentially not a number by itself. It only looks like a number to us. The point is, when it is actually read inside a computer and the computer wants to treat it as a number, it gets converted to type int, which is just 4 bytes. It does not care whether the number was 1 2 3 4 5 6 7 8 or 1 2 3 4 5 6 7 8 9, which is 9 characters, or 1 2 3, which is only 3 characters. All of them, if they are of type int, would use 4 bytes of storage inside the computer. Of course, if I had a bigger number, right, 1 2 3 4, let's say 20 digits long, there is no way that that can fit within 4 bytes. I would need some other representation in order to actually store it, not int, right. I might have to use a long or a long or some other kind of storage which is 8 bytes or possibly even more than that, right. The point is, that is how numbers are actually stored internally inside the working memory of the computer. But this visual representation, this is what we as humans actually see of it. So as you can imagine, once again over here, if I want to sort of store data into an external memory or external storage, I need to go through an API or an application programming interface, right. So this is basically like the system calls. It's a set of functions provided to you by the runtime of the programming language that says, okay, you want to, let's say, get a character out of a file, use the fgetc function. You want to get a string of characters out of a file, use fgets, right. And similarly, you want to write a string of characters out into a file, use fputs, right. So there are many different sort of functions that are provided to you, and these are pretty much the standard way by which you interact with a file, in text mode at least. Okay. Before we get to some examples of this, it's worth mentioning that you remember the special files that I had mentioned, which are stdin and stdout. As we will see later, the fgets function, when applied to stdin, has another name which is basically just gets, right. So get string and fgets from stdin are pretty much the same. Similarly, you might recall that we have already used the functions scanf as well as printf multiple times in different contexts. fscanf and fprintf are exactly the same as those, but applied to file pointers. Now if I do fscanf from stdin, that is exactly the same as just running scanf. If I do fprintf to stdout, that is exactly the same as running printf, right. And you probably also remember that I mentioned a third file called stderror, right. that it turns out does not have a shortcut. So I can't just give printf and expect it to go to std error. I have to explicitly use fprintf std error if I want my print output to go into the std error standard file, right. Now one thing to sort of be aware of and keep in mind over here is C is a little confusing at times, right. There is a function fgetc which can be applied to stdin, right, which is used in order to get a character out of stdin. But you might be tempted to think that the getc is just the equivalent of assuming that you have stdin already in the argument and therefore it is just fgetc with stdin applied to it. That's not really the case, right. So the getc is a slightly different function. It actually, you still have to provide getc from stdin, and what it will do is pull a single character out from stdin. Okay. The difference between getc and fgetc is a little bit more sort of involved. It's not something that we need to worry about at this time. Just keep in mind that unlike the fgets and fputs and fprintf and fscanf, fgetc and getc don't have a direct relationship between them. So let's look at an example of a function where we make use of the fgetc function called from C in order to actually access data from a file, right. So what we are going to do over here is, as before, I am going to open a file, and in this case the file that I am going to open is this file called test.txt. Okay. So let's just quickly take a look at what test.txt contains. In Replit, because it's a text file, I can actually open it, right, and if I do, then I'll see that it has like 3 lines over here. Well, technically 4, the 4th line doesn't really have any data in it, but there are 3 lines of text present over here which are readable, right. So in other words, when I actually open this file, I can see that yes, it clearly has some data that I can read and understand. I can naturally sort of get the thing that yes, this is a text file, this is what I would understand by a text file. Okay, so now what happens? I try opening that file. If I am not able to open it, I should print out a message and return, right. But in this case, I expect it to pass that test, right. It should get past this and come down here. Now what am I going to do over here? I basically declare a character, and then I start reading characters from the file that I just opened from fp. So the notation that I use is fgetc, and I give it the argument fp, right, that I just opened. Okay. So fgetc, by the way, when you look at a function like fgetc, you might notice the help that Replit provides says read a character from stream, right. And remember, as I said, a stream just indicates a stream of bytes. It is sort of another alias or a different term that is sometimes used for indicating the contents of a file in C, right. So that's why it says basically file star, and it basically, rather than calling it a file pointer, it basically says it's a stream. Okay. So you might come across both of these terms used for indicating what is what access to a file is required. So what we do, just like in the case of the fp, right, we call the fgetc, we assign its value to ch, and what we do though is that ch, we normally expect it to be a character, right. What do I mean by a character? It means that for a text file, I would expect it to be either an ASCII A to Z, or a capital A to Z, or a number, or space, exclamation mark, punctuation, something in other words that I can actually read. In this case, one thing that happens is there is this special term EOF that is used, right, and when you hover over EOF, you will actually see that EOF is defined as the value -1. What is this hash define? We will get to that later when we actually talk about the preprocessor, but for now the important thing is to keep in mind that EOF is the value -1. So let's say that I try to get a character from the file pointer, assign that into ch, take the return value of that assignment. I have to first make sure I did not get back the value -1, because a -1 is used to indicate that something went wrong, or more importantly that I reached the end of file and therefore could not get any more data when I tried reading it. Okay. So I perform this check while ch equals fgetcfp is not equal to EOF. If it's not equal to EOF, it basically means that it is some valid character and I can do something with it. what do I do with it? In this case, I am actually going to print out, right, something saying, okay, what is this character and so on, right. And finally, in this case, I am also going to print out EOF equals something something in what the value is over here, just to sort of see that you actually have the value -1. Now this while loop over here will keep going through the entire file and printing out a lot of information. So let me sort of trim this down, right. I am just going to make a copy of this file, and in the original file over here I will just remove these lines, right. I do not want it to sort of print too much data. Alright, so what do I expect this program to do? I expect it to read individual characters and print out those characters using %c out here, right. So each and every character that is present in test.txt, which is basically one line of text, it should print out when I run, right. And you can see that yes, it did that. It basically fetched one character at a time. It got the capital H, then the E, L L O space W O R L D exclamation, and then finally over here what you see is it actually printed a new line character. In other words, we have the quote starting on one line and quote ending on the next line, right. So in between those is basically the new line character. This is how it got printed. And finally what it does is it just prints out this message saying EOF is equal to -1. That's, well, we already knew that. We could have just checked the definition of EOF, and yes, it has the value -1. So what this has done, in other words, is we use the function fgetc in order to pull out characters from the file one at a time, and we use printf, right, which we have sort of been implicitly using all this while without really thinking too much about it, in order to actually print that out. Now if we start thinking about printf a little bit more carefully, you will understand that what is actually happening over here is we are using some kind of a file function. We will see the fprintf function later, right, in order to actually send these characters out, this string as well as this formatted character, out to a stream of bytes. And the operating system knows that that stream of bytes needs to be displayed in a certain way on what is called the console. So on this right hand side, this thing that you see over here called the console is precisely providing you an interface to see that stream of bytes that comes out as the std out of your program. Okay. Alright, so that was for the getC function. Let us look at the other variants of that we can use in order to access data from a file. In particular, we are first going to look at the fgets function, right. And fgets in this case, what it does is once again the same routine, right. I declare a file star fp, I try to open it, and once I have done that, I am basically going to print some, now I need to read one line at a time, right. Now in order to read a line at a time, fgets is not going to return individual characters, it is going to return a string, right. And what it does in that case is that I actually say try and get into the string s, which I have declared out here, right, up to 1024 characters. Okay, why am I saying up to 1024? Because this number is sort of given as a hint to the fgets function, right. I cannot guarantee that I will actually get 1024 characters, because it may be that I do not have 1024 characters on that line, right. And where should I get it from? From fp, which is the file pointer that I have just opened. Okay. Now interestingly, fgets, unlike fgetc, does not return a character. What it does is it actually returns a pointer, right. So I need to check whether the return value that I got was null. As long as it is not null, it means I have something to proceed with. The moment it becomes null, I break out of the while loop. So this program, as you can see, what it's going to do is it's basically going to read strings of up to 1024 characters. But the interesting thing about fgets is it does not just read 1024 characters at one shot. If it hits a new line, that is to say the end of a line which is appropriately defined, in this case using the new line character, it stops and returns that line to you, right. And in this case what it's going to do is print out string and we can also check what is the length of that string. And finally, of course, we have close FP because we are following the rules, okay. And let's see what happens when we run this. Just clear the console first and run it. So you can see that it basically printed out, it fetched that first line, hello world, including the new line at the end of it, and printed out this message saying that the string length of S was 13. Now how is that? We basically have 5 letters for hello, space is 6, another 5 letters for world, which makes it 11, the exclamation mark is 12, the new line character is the 13th character there, right. So the string length becomes 13, and since it has read it in as a string, we know that in C we basically have null terminated strings. So we can be sure that the 14th character in this array S is going to be the character 0, right, the null termination corresponding to the string. So what happened here, in other words, is we tried to read 1024 characters, it did not find that many, it read, well, 13 and gave that to us as a result. No errors, no problem at all, right. Now obviously we have only one line of text out here, so let me just get this original data back, right. This is why I had multiple lines out here. What I am going to do is to take it back to this state, right, where I have multiple lines sitting in the text file, and now when I run it, what I find is each time it actually reads the entire line including the new line character, which is why when I print it out using %s, it prints the new line character and sends that closing single quotation mark to the next line, and it says the length of the first line was 13. The second line was and then again goodbye, full stop, followed by \n, which is the new line character, and if you add up all of this, you will find that it is actually 25 characters. And the third line says pi to 2 decimal places is 3.14, and then I have a new line character, and when I add everything up, I will find that the length is 31 characters in that string, okay. So fgetS, in other words, is reading a string at a time. How is a string defined? It does not stop at a space, it stops at a new line character. That is basically the definition in this case. It gets, in other words, one line of text from the file. Now this is actually one of the reasons why fgetS is clearly considered a text mode access to a file, right, because in a binary file you do not even have a concept of a line, you just have data sitting inside the file. You do not know what is the beginning of a line, the ending of a line, you have a bunch of numbers sitting over there. So fgetS can actually only work successfully if you explicitly have this notion of lines, right, and you know that you are trying to read one line at a time and then process it appropriately. Okay, so that is as far as fgetS is concerned. Now let us look at the fscanf, which is the next sort of step beyond that. So in order to fscanf or to retrieve data using the fscanf function, fscanf, we have already seen what scanf does, right. It allows us to read, for example, a number or a character or even a floating point number from the input, okay. In this case, fscanf will allow us to read from a file, which once again we have opened appropriately in this way, right. So what I am going to do first is to run a couple of different functions, right, and let us just see how this works. The file that I have, test.txt, basically contains 3 lines, but interestingly in fscanf, right, this is what is called a formatted input. When I ask it to read a string, right, what it does is it does not actually read the entire sort of line, unlike fgetS. So let us look at this by sort of commenting out and getting one line at a time out here. If I run just the first line, in other words I just run a single fscanf and I ask it to get a string from the file, what happens is that I actually pick up only one word, only the hello, and the space that came after hello is actually missing, right. The length is exactly 5, it has not taken the space as part of the word. So what it did, in other words, was it scanned through this first line up to the first what is called a white space character, and white space essentially indicates it could be a space character, it could be multiple space characters, they are all collapsed together into a single white space character. It could be the tab character that is sometimes used in order to separate or to indent code, etc. Or it could be a new line character which basically says go down to the next line. Any of these things are considered white space. What scanf with a string operator does is it goes up to the first white space character and stops there. Okay. So alright, what happens if I now just run this once more, right? I find that it now prints out hello with the length of 5, world exclamation with the length of 6. Now the interesting thing is, if you look carefully at it, you will realize that there was a new line character right at the end of that, which this doesn't seem to have picked up. It stopped at the new line character. Did it read that new line character? We don't know, right? And the short answer is no, it does not read that new line character out, right? I actually can, we can try that by basically uncommenting this and running it. When after the fscanf, the two fscanfs, if I run a fgets, it just basically reads a single character out as a string, right? In other words, what has happened is I have done the fscanfs, the position in the file has actually moved up to a certain point, which means that now when I run fgetS, it's not reading from the beginning of the file, it's reading from wherever the fscanf stopped, right? So there is, along with this file pointer, inside that file struct, there is some kind of an index that is keeping track of where inside the file we are currently, right? So the two fscanfs basically took us up to a certain point, and after that if I run fgetS, it turns out that I am actually going to read up to the end of that line, but starting from wherever I left off. In this case I had actually almost reached the end of the line except for one character, the actual new line itself. So the fgetS only retrieves that for me. It ends up giving me back a length 1 line which only consists of a new line character. What happens after that if I again run a fgetS? Well, the second time around it's actually going to read the entire second line, line 2. Okay, so all of this and then again goodbye, all of that gets read with a length of 25 just like we saw earlier, right? It reads the whole line in. So far so good. This was sort of used to demonstrate that I could have pulled out either one word at a time or one line at a time, right? And that if I do some amount of reading and then if I again call another function, it will then start from where I last left off. Okay, let's go further because the third line is actually quite interesting in its own way. It has some extra data out there, and we know that we have already seen the third line says pi to 2 decimal places is 3.14. For me, what I would like to do is get this number 2 as a number and this number 3.14 as a floating point value, right? Read them in there. But then I don't really care too much about the rest of the text around it. That's where fscanf can be used, right? It basically says, okay, what if I give it the string with which to read, right? And I basically say fscanf from fp, right? But with this string which says pi to %d decimal places is %f. In other words, I am saying that after the pi 2, I expect to see an integer, and after the places is, I expect to see a floating point number, right? And I need to give, remember, scanf takes the address of a variable so that it can actually update the value of that variable. Same way fscanf does the same thing as well, right? And I can give address of d and address of p, and let's see what happens when I actually print those values out. Yeah, so you can see that the rest of the text remains exactly the same, and the last couple of lines I have decimals as 2 and the value as 3.14. It's got printed out as %f, so that added a few more decimal places, a few more zeros after it, but the important thing is it actually read it in as a floating point value. Okay. Now this looks interesting. What happens if I make a spelling mistake out here, or if I change the line from which I am trying to read? Now you will see that I have p to %d decimal places is, and what fscanf is trying to do is it's trying to match this text that it sees over here with what it actually sees on this line, and it basically says there is no match, I am unable to read anything, right? So what happens? it doesn't fail. Well, C never really gives you, saying never gives up, right? It gives you some result always, and the result it gives in this case is that the number of decimals is 32,767 and the value was 0. That's just coincidental, right? Each time you run it, those numbers are going to change, right? So in other words, this is a clear indication that it basically, the scanf did not succeed. It could not get the right thing out there, okay? So remember that you can do formatted input, right, provided that you have your strings to skip over defined exactly right, right? So provided I have the actual spelling pi in this case, it is able to pick up the integer from the correct place as well as the floating point value from the correct place. Now there may be scenarios where I don't really want to give it the exact string, I just want to sort of read and ignore certain values, right? If that's the case, I could use another format of fscanf which basically looks like this. I give percentage %s, but I give it as percentage %s, and what the percentage star and the formatting thing is saying is that read a string and then just ignore it, right, dump the value, right. I don't really care whether it was pi or PIE that is present out here, I just want you to take the first word and discard it. I know that there is a space after that, okay, and I know that there is another word after that, again read that and discard it, but after that I know that there is a number, and then again there are like 3 strings out here, read all of them and discard them, that corresponds to the decimal, places, is. So 3 string values are read and discarded, and then I get the floating point number after that. Well, does this work? Yes, it does, right? I can get the number of decimal values, decimal places, and the value of the floating point number that I read out from there. Now the interesting thing is, even if I change something out here, right, change the spelling for example, right, and then run it, it works because it's just reading in an entire function. But what happens if I add an extra character out there? Now what has happened is I was expecting to see 2 strings and discard them, right, but this has 3 strings that I need to discard, and once again we are back to getting garbage out here, right. So as long as you are careful with what we have and that you know exactly how to read formatted data in, fscanf can be a very powerful way of getting the data out that you need.